At this stage, I would like to sort of introduce the moderator for the first panel and the speakers. He can introduce them. So Charles Taylor will be the moderator for the first panel. Charles is a student in the Sustainable Development PhD program, just finishing up now. He's going to do a postdoc, I guess, in Berkeley next year and then going to Harvard Kennedy. And please, Charles, take the floor.
So this morning's session is about the unequal effects of climate change. And when you think about the research on this topic, a lot of it's been focused on aggregate and average effects over time, right? I mean, these are these big changes, and we're trying to understand what's the social cost of carbon, what's the marginal damage of something happening. But an increasing amount of exciting research is going into some of the inequalities and heterogeneities that we see in both the impacts and the policies associated with climate change. So this session is going to focus on those topics. So both the unequal nature of where climate change is occurring, so some places are getting more hot than others, some places are going to get more storms than others. What are the distributional effects of that? And then a second strand is related to differences in our ability to adapt to climate change, in particular extreme events like flooding, right? And that might exacerbate inequalities as well. And then finally, when we think about policy responses, how do we mitigate some of these damages or help communities adapt? What about some of the unintended consequences in response to climate change and flood mitigation as well? So with that in mind, the general structure of this session will be there'll be 3 speakers. They'll each present for 30 minutes, and then we'll have a 15-minute question and answer period. To very briefly introduce the speakers, there's first is Anna Varela. She's an assistant professor at the University of Amsterdam in the School of Economics, and also an alum of the Sustainable Development PhD program. We have Clara Barasiki. She's a PhD student at Columbia in the Sustainable Development Program. And then finally, we have Christian Blickley, who's an economist here at the Federal Reserve Bank of New York.
Thank you, Charles, for the introduction, and thank you so much for having me. I'm really excited to be here amid such a great panel of speakers. I'm really looking forward to the conference. So as Charles mentioned, I'm going to present a project titled Search of Inequality, How Different Neighborhoods React to Flooding. And what this paper investigates is how different places with different characteristics, different residents, evolved after a flood shock. And what I'm going to show you that these responses were really varied and heterogeneous. And this heterogeneity led to rich places becoming richer and poor places becoming poorer after a flood. So overall, this natural disaster acted as a surge or a wave of social economic inequality. So let me start by motivating why this question is interesting and worth asking. Floods are a costly natural disaster. The US Geological Survey estimates that floods are the most costly natural disaster during the 20th century in terms of damages to properties and lives lost. This is not only a problem now, but is expected to worsen in the future, specifically in the northeast coast of the United States due to sea level rise and expected changes in hurricane activity in the northern Atlantic. So it has become imperative to understand how different places react to flooding, and urban and environmental economics research in those fields have been busy at doing that. And it has found different effects in different contexts. So for instance, Ortega and Taspinar investigate property prices in New York City, just in New York City, after Hurricane Sandy in 2012. And they find that flooded properties declined in prices 8% compared to nearby non-flooded properties. And this decline continues to stay this permanent at least 5 years after the flood. In a different context, being on Landry in Northern Carolina, find that prices actually also go down, flooded property prices see a decrease in prices that revert to the mean after a few years. And then yet in a different context, Ralph Sebeen and co-authors investigate a series of hurricanes in Florida and find actually that flooded properties increase in prices compared to nearby non-flooded properties. So and to find evidence of these different divergent recovery paths, we don't have to investigate different contexts. We also find evidence of those at a very micro neighborhood level. So I'm here in this image, I'm highlighting 2 counties of the New York City area that were similarly affected by flooding caused by Hurricane Sandy in 2012. To your left is the county, the borough of Queens. And what happened there is that flooded properties compared to nearby non-flooded properties saw a decrease in prices of 19%. On the other hand, the graph on your left is highlighting the nearby county, Hudson County in New Jersey, where using the same methodology, similar data, we find that properties actually increased in prices. So the reasons why we see this differential prices or evolution after a flood are not well understood. And moreover, we don't understand to what extent these differential paths interact with existing place dynamics like urban decay or gentrification. And this is at a time in which economics, the literature in economics is highlighting the negative effects of spatial segregation. Notably, work by Racchetti and co-authors at the Opportunity Lab at Harvard University find that the characteristics of a place, of the neighborhood at a very micro level one grows in, has impacts on outcomes later in life, like wages earned or patents one files. Also, recent research finds this feedback positive loop between spatial segregation and socioeconomic inequality. So in this context, what this paper does is ask whether these differential paths, we see recovery paths at a neighborhood level, counteract or rather exacerbate existing spatial inequality. I'm going to investigate this question in the context of Hurricane Sandy, which, as I'm sure you are aware, affected the northeast coast of the United States in October 2012. To date, it's still the 4th most costly natural disaster in the US, only after Hurricanes Katrina, Harvey, and Maria. It's a compelling setting to investigate heterogeneous impacts of flooding because it affected, as I'm going to show you, a wide range area, geographical area across 4 states. To investigate this question, I compile a rich data set that includes, among other data, flooding across these 4 states, property prices, and the race and income, socioeconomic demographics of the buyers of these properties. The richness of this data, specifically its fine level of geographical detail, allows me to investigate how different neighborhoods, again, at a very fine level, react or evolve after a flooding. As a quick preview of the results I'm going to show you in the next 20 minutes, indeed what I find is that Sandy, the flooding caused by Sandy, exacerbated pre-existing polarization across property line and the socioeconomic demographics of these buyers. As a summary of this result, this figure that I'm going to show you later as well, plots the evolution of property prices. The blue line is properties that eventually were inside Sandy's floodplain. In orange is the evolution of properties that still coastal were not flooded by Sandy. On the x-axis in both graphs, we have time. And what I'm plotting on the figure that you're seeing on your left is how property prices in the poorest of places in my sample, in the bottom decile, evolve before and after Sandy. So what we see is that before Sandy, we don't see that they were following more or less similar trends. Then when Sandy hit, properties that were on the floodplain saw the prices drop significantly, and they stay below what nearby non-flooded properties are. When we look to your graph that you see on your right, which plots the evolution of prices in properties located in the richest of places in my sample, we see no evidence whatsoever of the drop of flooded properties after Sandy. Not only that, but prices for flooded properties are above those for non-flooded properties after Sandy. For the 4 years, we have data for after Sandy, and this is something that hasn't happened in any of at least in the 10 years prior. So in the 20 minutes I have left, I'm going to follow the usual outline. I'm going to first start motivating with a conceptual model how it would be consistent with economic theory to see prices drop after a flood, once we take into account that we have a preference to live in certain places and among a certain type of people. Then I'm going to describe in a little bit more detail the data I use, the empirical strategy that I use to analyze this data, present the results, and conclude. So why do we see, how can it be rational to see property price increase after a flood? So for that, I built on the model of segregation by Gary Becker and Kevin Murphy. Very simplistically, this model assumes that in equilibrium, property prices are going to be higher in places that have either valuable amenities, like a nice beach in a coastal location, and or high-income residents or residents that have socioeconomic demographics that are correlated with high income, like race. And the reasoning behind that is that there are positive externalities of living among these residents, like network opportunities, better schools, a prestige signal. What I then assume is that this system in equilibrium is shocked by a flood, and I made two assumptions. First, that the flood is a disamenity for every resident. No one likes their neighborhood to be flooding. All residents like their neighborhood less after the flood. But then second, I also conceptualize the flood as as a wealth shock, and assume a diminishing marginal utility of wealth. This assumption in turn has two consequences. The first is that low-income residents are going to derive a higher disutility from the flood. This is because they're less able to reconstruct their properties after the flood, less able to retrofit them in preparation for the next storm, or less able to face higher insurance costs. And then this assumption of the flood as a wealth shock also has the consequence that this utility shock is going to be higher for the more expensive the properties were before the flood. Again, they were harder to retrofit, harder to insure. So with this model in equilibrium and this assumption about the shock, this yields two predictions. First, we are going to see low-income residents retreating from flooding neighborhoods, specifically those that had higher properties to begin with. High-income residents, even if they dislike their neighborhood more after the flood, they're better able to scope and stay. And then we have two forces at play. On the one hand is the flood, that is a disutility. Everyone likes their neighborhood less after the flood. But on the other hand, there is a higher percentage of high-income residents, and we assume that there are positive externalities derived of living among them. Everyone likes that. If this second force happened to be higher than the former, we could see property price increase after the flood, even if the flood risk is internalized and all agents are rational in assuming a decrease of utility or less amenities in their neighborhood. Okay, so given that, I'm going to move on to then describe the data I'm using in this paper. As I mentioned, I don't know if you can see the map very well, but I'm focusing on the 4 states more affected by Sandy, which are New Jersey, New York, Connecticut, and Rhode Island. For these 4 states, I first gathered data on my dependent variables, which are property sales. This comes from a proprietary vendor, CoreLogic. I have a 15-year series. This is CoreLogic basically makes available the universe of property sales in these states. So I'm going to explain in a second that my empirical strategy focuses on properties that are on the coast. So these are the dots in orange that you see on the map. I am able to locate the longitude and latitude of the properties that are being sold during the period. Beyond the property prices available on CoreLogic, I'm also able to derive the race and income of the buyers for a subset of these sales. I'm able to do that merging the CoreLogic data with data that is publicly available under the Home Mortgage Disclosure Act. And I use a methodology that has become common in the literature. Then I also want to investigate what are the characteristics of the places that see divergent effects. So for that, I'm going to compile a rich set of characteristics on using data from various sources like the Census and the Opportunity Lab at Harvard. Then I have data on Sandy's flooding, thanks to a map that is, again, made publicly available by FEMA. So what is the empirical approach? How do I measure effects? This is what I'm showing you in this graph. It's a zoom in on my area of study. So you see the orange dots are the properties that were sold, at least once in the period. Different shades of green and blue is the flooding. So there's research that determines that people that choose to live on the coast may be different along some observables to people who choose to live more inland, like in terms, for instance, of awareness of climate change or their beliefs that sea level rise is actually going to happen. So to avoid that, I'm going to focus on, or to avoid making apples to oranges comparisons, I'm going to focus on a narrow band of properties along the coast. So this is the red dashed line you see on the map. This is a line that marks 500 meters from the coast. So 500 meters, which is around 1,500 feet, it's a distance that one can walk in 6-7 minutes. So what I'm going to do then is compare in a difference in difference framework properties that were flooded with nearby non-flooded properties. So properties that were inland, so all the orange dots you see inland, not in this bundle of the coast, I'm not using. Okay? So I compare again a difference in difference properties in the floodplain, outside the floodplain, after and before Sandy. Then to understand how different characteristics, or how places with different characteristics see different effects, I interact this difference and difference model with place characteristics in a triple difference framework. Finally, I complement this analysis with a machine learning methodology that allows me to systematically measure heterogeneity. The main benefit of this approach is that it allows me to be agnostic as to what are the characteristics of the places more or less affected by the flood, and lets me actually check if indeed it's the income of the place, the variable that better discriminates these places. So this is a methodology developed by Ivan Chernoshukov, Esther Duflo, co-authors at MIT, and used, for instance, by Tatiana Deyugina and co-authors in a recent AER paper. Very simplistically, what this procedure allows me to do is for each observation create a counterfactual of itself. So what would have been the price if this flooded property were not flooded, or vice versa? So it allows me to rank my observations along the estimated treatment effect. So among other things, I can group these observations according to this predicted treatment effect. If the flood affected all properties homogeneously, if all share a similar drop in prices, I should see that, again, the effect in these different groups should be the same. There should be no statistically significant difference. It would also allow me to investigate what are the characteristics of the places where these properties in the different groups are located. So now I'm going to move on to the results. How much time I have left? Yeah, I'm good? OK, great. So I'm going to present this result first, the average effects, and then go into the heterogeneous and the machine learning results. So on average, these are all the properties on my sample. It's a similar equivalent figure to what I showed you early on. On the y-axis, we have the evolution of prices. On the x-axis, we have time. And then Sandy hit at the end of 2012. And again, we see the evolution of prices in orange, the properties outside the floodplain, still coastal, but outside the floodplain, and then in the floodplain in blue. And we see that the evolution of prices was more or less parallel before Sandy hit, and then when Sandy hit, flooded properties saw a drop in prices that again stays constant until 2017. So basically the results that Ortega and Taspinar found from New York City are found in this larger sample of 4 states. Then I also investigate or allow the flood to be a continuous treatment. So rather than use, as I showed you in the previous picture, flood as a binary variable, yes or no, I check if flooded properties that were more flooded in the sense that they have higher flood depths saw differential effects. So what I'm showing you in this figure here, on the y-axis is still the evolution of property prices. On the x-axis is distance to the flood level, the local flood level. So negative values are properties that were flooded. The higher in absolute value this flood depth is, the higher the flood depth for a given property. And then positive values are properties that were non-flooded. And the higher, again, in positive, the flood depth is the further away a property was from the flood. Okay? And now orange represents the evolution of prices before Sandy, basically a summary of property prices before Sandy, and in blue after Sandy. What we see is that in the orange line, there was no change when the flood limit before, and this is consistent with residents not being able to predict exactly where the flood was going to come, so we don't see evidence of sorting along this flood limit. But then when Sandy hit, and this is the blue line, we see that non-flooded properties, the prices haven't changed much, but then there was a significant change in the prices, again, for flooded properties. We see that properties flooded even with small flood depths, even half a meter, so a drop in prices. And then we see somewhat of a U shape in the sense that or properties with higher flood depths actually see a slight increase in property prices. They would be consistent with there being a coastal premium, say, even if properties in a very front line near a beach, even if they were very flooded, there is still a premium to live in there, and the drop in prices was not as significant. Now, we move to understand the socioeconomic of the resident. And we see what I'm showing you in blue is the effect I just showed you in other graphs, basically that there was a drop in prices after the flood. But we also see that these drop in prices came together with a change in the socioeconomic characteristics of the buyer of these properties. And we see that they were less likely to be, these buyers were less likely to be high-income white residents. And this is a variable that composite variable that basically highlights the likelihood of being a high-income and white, meaning the more likely you are to have those characteristics if you rank high in this variable. So these are average effects, but then I want to understand if these average effects are masking heterogeneity. And this slide summarizes the results from the machine learning procedure and highlights that indeed there is. So on the x-axis, I have the different groups. Again, these are the groups of my observations ranked from the lowest, meaning the highest in absolute value, but negative, towards, and this is the group number 1, versus the 5th group, which is the 20% of the observations with the highest treatment effect. What we can see is that this average treatment effect of around 9%, a drop of 9% in property prices, indeed masks great heterogeneity. We have the 20%, we estimate the 20% of the properties that saw the largest negative drop in prices actually lose around 30% in prices, whereas there are some properties, 20% of the properties actually see an increase after the flood of 20%. So again, we see that this average effect is masking what is actually large heterogeneity between different types of properties. Right? This difference between the least affected, most affected group is 50 percentage points and is indeed statistically significant. So then what I do is I investigate what are the characteristics of the places where these properties in the first group versus the 5th group are. This is what I'm showing you in this slide. So what I do, I collect a rich set of characteristics that they combine using principal components analysis in categories, again, following a common approach in the urban economics literature. And what I find is that the variables that very discriminate these places more and least affected by the flood are secondary education and the income of a place. These are two variables that have a high correlation in my data. So basically, properties most and least affected, the variable that better discriminates them, again, is the income of a place or secondary education. Other variables that the literature has highlighted as being determining behaviors after a flood, like different measures of social capital, in this setting are not as good at discriminating which places are going to gain or lose after the flood. So after identifying and again corroborating the fact that the income of a place actually determines evolution after a flood, I go ahead and investigate how places with different incomes behave after a flood. And I'm showing you here the image I showed you at the beginning, basically the evolution of prices, but now I distinguish between those properties located in the poorest of places to your left and the richest of places to your right. Again, we see how the different evolution of prices, basically the heat, the large heat for properties in the poorest of places, and the non-existent drop basically in the richest of places. I also do repeat the analysis with this continuous treatment of treating the flood as a continuous treatment. And we see again on your left for the poorest of places, on your right to the richest of places. And we see that again before the flood there was no difference for flooded, eventually flooded and non-flooded properties. But when Sandy hit in the poorest of places, there is a drop, a significant drop in property prices. And in the poorest of places, we don't see evidence of this rebound for more flooded, arguably more coastal properties. Then for properties in the high income places, the results, the confidence intervals are larger, are noisier, but we basically again see no change in property prices for properties that were highly flooded. And not only that, but we see that for lower flood depths, flooded properties the prices of those are above those of non-flooded properties. I then also investigate what are the socioeconomic characteristics of the buyers in these different places. And I'm showing you above the first two rows, summarizing the results for the complete sample, the average results, and see that on average, property prices went down and they were less likely to have high income white buyers. And this is actually indeed the case for properties in the lowest income places. However, we see that in the highest income places, the signs are reversed and property prices are increasing, and these properties in these places are more likely to have a high income white buyer, which is a result that is consistent with this conceptual model I presented to you earlier. I have some further results that we can discuss if there is a question about them. I investigate if insurance policies, flood insurance changes across these places. And as a snapshot of those results, what I find is that the low-income places actually see a decrease in the number of policies. So basically, these properties have lower values, have buyers with lower incomes, less likely to be white, and are buying less flood insurance. And this is in a context in which actually the premiums for flood insurance are going down. I also don't find that high-income places see higher public assistance, basically higher funding from FEMA. You might be also worried that these changes in high-income places is coming from high-income buyers buying better houses, right? Maybe newer construction, etc. I don't find evidence of that. I don't find evidence that these high-income places see more new construction. I also don't find evidence that places that are recently flooded, there was a large flood caused by Hurricane Irene in 2011. Basically, these places were very prepared for the flood. I also find that another worry you may have is that these high-income places see less damage. They were very prepared, and maybe this is what we are seeing here. But even if I compare properties that have an objectively similar level of damage, I see a premium in prices for being in high-income places. So now let me conclude in the last few minutes I have. What I show you is that the flooding caused by Sandy deepened existing spatial polarization pre-flood in the sense that rich places, high-income places, saw property price increases, higher income buyers, and the opposite for low-income places. And these results would be consistent with a model of neighborhood segregation in which low-income households are more affected, derive a higher disutility from the flood. And this paper improves our understanding on on different recovery paths we see after flood in different contexts. This result has important policy implications. After a flood, we see a duality happening. On the one hand, there are places that are becoming poorer, lower property prices, lower count of flood insurance. So we see these places becoming more and more vulnerable, in the face of the inevitable next storm. But then on the other hand, we see these high-income places becoming rich enclaves, become higher property prices with higher income residents, which might soak up regressively or using, their influence after flood, after again the inevitable next flood. So successful after flood policies and flood insurance reform will need to take into account or considering this duality that takes place after a flood. And that was all. Thanks so much for your attention. Looking forward to your questions.
So, anyone have any? I heard maybe a very tiny questioner in the back that might have one. Sure.
Yeah, indeed, it could be that we see our control group is so nearby affected by the flood. What I do to alleviate these concerns, I do in an event study, basically test whether in my control group I see changes in property prices and in the socioeconomic demographic of the buyers, and I don't find evidence of that. Basically, I don't see a statistically significant difference on that. Indeed. So these results wouldn't get at that point. I only find that on average, the socioeconomic demographics of my control group haven't changed. It might be very well be what you said. There was some sorting, and for that, that is something that I hope to investigate later on. But you're absolutely right.
All the way in the back.
Yeah. I can. Yeah.
You're saying that vulnerable areas, you get the more affliction.
Yeah, the thesis is that the same flood affects differently different types of places. So
when you talk about the difference is those you kind of extrapolate from that black and brown or income, whatever proxy.
exactly.
So my question is, did you, when you went to the insurance, because to lift a house, because when the areas you look at, to lift a house, to rehab a house, all those materials, all those labors are equal. It doesn't really matter.
Yeah.
A plywood is plywood, 2x4 is 2x4, lifting the house is lifting the house. So my question is, if you're maxing out at the FEMA 250,000, is there, when you went, and I don't know if you were saying something there about the insurance and some differentiation in the insurance. Are you talking about just something with that, because of property values, these homes will never get to the same cost of a piece of plywood, the same cost of lifting a house? They will never get there because of the original value of the home precludes insurance, which is government money, which is $250,000 maximum of insurance, precludes that from ever occurring?
Yeah. So that's a good question. I find and I evaluate how property price change at a very fine level of detail, right? I know exactly where properties are. I have the longitude and latitude, and I can evaluate changes in that. For the flood insurance, for privacy purposes, this data is publicly available, but is anonymized. So I'm not able to know if a particular property had flood insurance, how was the claim, etc. I can only aggregate flood insurance at the census tract level. So then what I find is that, if this works, no, never mind. So that the census tracts for the poorest of places, I see a drop in people taking up insurance. But again, I'm not able to identify if a particular property was sold at a loss because it didn't have enough insurance money to basically be rebuilt. That is something that, again, I cannot evaluate given the data. But again, I do find that these places that saw property prices drops have a lower number of properties insured after the flood, and actually that on average, the premiums are lower. Yeah.
Your graph completely follows patterns of predation. That is a predatory group. And so did you look at that as a factor, just predation?
No, that's a good point. Yeah, indeed, that is not visible in the high-income places, but in the lowest-income places, we do see the graph mimics the housing boom and then boost after 2008. And indeed, this is not apparent in the high-income places. I do not use that in this paper as an explanation as of why different places reacted differently to a flood, but indeed we see evidence of that happening.
That's kind of an infrastructure phenomenon.
Yeah, and
Predation does go after the values because it undermines what rehabilitation is doing to the housing stock.
Yeah, and to your question, maybe I'm not addressing it, but going into this project, I was expecting to see gentrification. Basically, I was expecting to see in these lowest income places an influx of high-income white residents reconstructing these places. And basically, this is not what I find, right? I find rather an increase in the polarization. Poor places becoming poorer, high-income places becoming richer. I do not see low-income places being gentrified, at least in this context.
Okay, thank you very much. Any other questions? Sure.
Yeah, that's a very good question, and indeed, and also very relevant. FEMA is now updating the flood insurance policy. As of last month, there is a new way of evaluating policy premiums, and what they've done is something that is necessary. They basically have elevated prices for properties that get more and more flooded. So basically, the premium reflects the risk. However, given this research, it could be that the effect of that is making high, or basically expensive properties less affordable for the middle class. It's because of these high insurance premiums. And if that were the case, it could exacerbate these processes, right? Making basically properties in desirable coastal neighborhood less affordable for, again, middle classes, low income residents, but more or basically, even if high-income residents are going to assume they don't like their flood insurance premiums to rise, they're better able to cope. So in that the case, and I think in the last paper of this session, going to see some very interesting results on the unintended consequences of flood insurance, but that indeed could be one of the consequences.
You have them?
Especially with regards to resilience, flood,
Yeah.
by putting mechanicals up on the roof.
Yeah, indeed, those are very important questions. With the data I have, what I can answer is that these high-income places and low-income places didn't see differential trends in the number of new constructions being built, completely new constructions. Then the first part of your question was about rebuilding. And that is something that, unfortunately, in my data, I do not have at the moment. I see the price of a property being sold after the flood, but I don't have information as of yet to the extent to which it was renewed. What I have to alleviate some of those concerns are the characteristics of the houses that are being sold before and after. And I see that the houses that are being sold after the flood in high-income places are slightly larger, but like 40 square feet. So slightly larger, but very, very marginally. I don't think this small change in lot size, or basically in property size, can basically be the responsible for these changes in prices we see. I also, again, don't see that these houses have different construction year. So basically, they are, again, not new constructions. However, because of lack of data, unfortunately, I cannot answer your question more effectively as to what extent these houses were rebuilt after the flood. Yeah. Yeah. So the reason I'm stopping at 2017 is logistical. This is where my data stops. Unfortunately, I started this project 2018, so that was the end of the data. Indeed, it seems like there is some catching up, and that would be consistent with some of the results found in some contexts in the literature, being in North Carolina, find indeed that there could be a reversion to the mean, maybe new people moving in that didn't experience the flood, maybe some sort of, Bayesian update expectations. I haven't been flooded last year, therefore I'm okay. There could be some of that. It would be indeed very interesting to gather more data, see what's happening there.
Thank you. You had a question?
Yeah, indeed that is, and let me know if I am understanding your question correctly. Rather than waiting to see what will be the effect after the flood, what we can do proactively to avoid these changes. I'm not answering that question in this project. There is a lot of people doing interesting research on buyouts and what are the implications of those, where do we see buyouts in which sort of places, what are the basically consequences of that. Is very interesting, but with this data, I'm not answering that question.
Yeah, so if you have a question, I think go to the microphone because this is going to be recorded, so apologies about that. Any other questions? Okay, Doug.
Yeah. Yeah, indeed, and Also, let me say that I try to see if there is indeed a drop. I do a regression discontinuity sort of analysis at the flood limit. I do not find evidence of that. And that would be consistent with expectations about the flood not being dichotomous in the sense of I was flooded, therefore I'm worried, I barely escaped the flood, then I'm fine, but rather more gradual. And again, I don't find evidence of that. I do see a change in the trend, basically more flooded properties being more affected. Indeed, so in the low-income places, we see, as you were saying, a flatten out for larger flood depths. In the average, if you remember, it was even an increase, a sort of U-shaped, and this is, again, as you also pointed out, a speculation, but this could be that the more flooded properties are also more likely to be near, the first line of the beach, basically having higher amenities and being this coastal premium still being relevant even after the flood. And again, a speculation, but I think that could be behind it.
Okay, we have one more question. Sure. Do you mind going to the for the recording? Hello. So I'm looking at this figure. I'm maybe drawing too many inferences from like squinting at some dots and but one story. I'm wondering if any of your robustness checks can distinguish a story where buyers of houses in these two neighborhoods are just like treated with different information or have different levels of. I'll go with information treatment as a way of describing it, and. Maybe buyers in higher income neighborhoods have some expectation about their flood risk. And this happens, this is like a 2 sigma event. And buyers that are, this is only 1 meter to the floodplain. They're like, oh, that was a 2 sigma event, it wasn't so bad. And so their expectations about their flood risk actually decrease. But buyers in the lower income neighborhoods that maybe are treated with worse quality information about their flood risk suddenly have to update. Is there a way of distinguishing that story from kind of the model you set up at the beginning?
Yeah, that's a very interesting hypothesis. Yeah, again, I'm afraid that I'm limited by the data, but coming up to some of your perhaps concern, one, we could expect these residents of these different neighborhoods to update differently to their possibility of being flooded again, given public infrastructure that has been developed, right? If my house was flooded, but then I'm having a nice seawall being constructed, then I'm less worried. I do not find evidence that places that have a higher income received more public infrastructure assistance. So given that, that would not be the case. I also find that, as I mentioned in terms of insurance, that these lower income places have less flood insurance after the flood. So that would be against this story of basically them not being worried after the flood, whereas this high income residents see, or basically places, properties in high income places see relatively larger flood insurance take-up. Again, it's not pinpointing your question specifically, but it points out, yeah, that these differential expectations may not be the main cause.
Well, thank you very much, Anna.
Thank you. Thank you, everyone.
Hi, so my name is Clara Barasiki. Thank you so much for having me here. I'm so excited to present this project to you. This is a joint project with Wolfram Schlenker, and we are going to present on the within-city disparate temperature effects of climate change. So first I'm going to run you through some introduction and motivation on the project, then through the data we use, and then through some empirical results, and finally a short conclusion. So first, some motivation for this question as to why we're interested in looking at differential exposure to temperature at a microscale. So we know that minorities and low-income, low-educated disproportionately bear environmental damages. So we know that there's this differential exposure. As we said in the introduction, different groups are exposed to different environmental damages. But we have a lot of evidence on the distributional effects, for example, on pollution, but we have less evidence on differential exposure to temperature at such a microscale. And we think that this we might actually see this differential exposure at a microscale even in small geographic, at a high spatial resolution, because we actually know that temperature mitigation mechanisms such as air conditioning, heating, but also like thermal insulation or tree cover might actually be strongly correlated with racial and socioeconomic status. And so this is just like a motivation. So these two maps I'm presenting them kind of separately as to why we think this question might be important and interesting, but they're not directly related. So here you have a tree cover on the right, you have a tree canopy cover in New York, and you can see, sorry, I'm trying to get the pointer, but you can see that there's actually a lot of heterogeneity in the tree cover in the city. You can see a big, very dark green Central Park in Manhattan, and Staten Island, but you can also see that parts of the Bronx and of Brooklyn are actually have pretty low tree cover. So, and we know that tree cover is actually very important to mitigate outside air temperature. So it acts as a very strong regulator. And on the right-hand side, you have heat stress-related hospitalizations in New York from 2012 to 2016. And here you also see a lot of heterogeneity. So you see very dark red, so that means a lot of heat stress-related hospitalizations in the Bronx, in some parts of Brooklyn, and but you see a lot less in Manhattan, where we're standing right here, right now. So this motivates that there's actually, because of these adaptation mechanisms, because of urbanism, because of also discriminatory policies, you actually might have a lot of variation in how different groups are exposed to different temperatures, even within small geographic areas, such as within a city, such as New York. So this kind of our motivation. And we think that studying these differential dynamics might actually be very important when thinking of environmental justice, and also that documenting these trends could be important, for example, for local policymakers that want to implement policies geared at ensuring environmental justice. So now I will give you the main questions that we try to answer in this paper, and the answers we find to these questions. So the first question is, do we observe these differential trends by different demographic and socioeconomic groups? And the answer is yes, we do. We do see that different groups are exposed to different extreme temperatures, and that minorities, low income, the less educated are more exposed to extreme heat. And the second question we try to answer is we want to go a little bit deeper and to understand how different groups, how these differences play out. So it's, is it because different groups live in different parts of the US, or do you also see that effect when you look within a small geographic area? So, and we find that yes, you also have this effect. When you look within a small geographic area, you also have that different groups are exposed to different temperatures. And finally, the last question that we want to answer is we want to understand how these different exposures, how do they translate into different economic costs. So we want to translate this into amenity value. So how much do you value a certain climate? Like what percentage of your income is the climate you're exposed to costing you? You can think, for example, if you're exposed to an extremely hot day, that will translate to for a dollar value of your income that you can quantify in a dollar value what displeasure being exposed to this temperature is causing you. So that's what we try to get at. And lastly, we also want to understand if this taste translates into housing price trends. And what we find is that kind of in accordance with our previous results, that we see the differential trends. We also find that minorities, low income, and low educated, they do face higher economic costs from extreme heat. A little bit about what the literature, the academic literature, has to say about this topic. So first, as I touched upon in my introduction, so we know there's been a lot of work done on pollution at the microscale. So a lot of evidence has shown that exposure to pollutants bears disproportionately on minorities. So, and we want to take that analysis to understand what it is saying for temperature. So what do we have on temperature? There is a large literature on temperature and a variety of outputs, but not exactly what we're going to do. So in the temperature literature, there's a lot on temperature and aggregate output. So it's like the effect of temperature on GDP has been extensively studied by economists. But this stays mostly at a macro scale. So it's looking at differences, for example, between countries, and it doesn't really go at the micro scale as we are trying to do. And then, which is at the micro scale, there's also a large literature that is looking at the effects of extreme temperature on outcomes such as mortality, but also like productivity, showing that being exposed to extreme heat will impact negatively your productivity. And then there is also one paper by Xu et al. That has a close research agenda to us because they look at inequalities within cities. So they study the surface heat island effect within large urban areas. But so they only look at 1 year, 2017, and what we try to do in this analysis is that we really want to study the trends. We want to show how these differential exposures have evolved over the last 50 years, and they also do not have this economics cost dimension. So now I'm going to delve a little bit deeper into the data that we use for this project. So, well, we have a temperature data set, and we have a data set on demographic and socioeconomic data. So on the temperature data, our baseline data set is called TOPO-WEX. It covers the last roughly 50 years for the conterminous United States. And it's based on interpolated station data. It complements that interpolated station data with MODIS, so it's a satellite measuring the temperature on the ground, which is different from the air temperature. So it combines these two sources. And the great thing about this data set is that it's super detailed. It's on an 800 meter by 800 meter grid. So this is really something that we want to study different in socioeconomic groups and demographic groups because, for example, in a city like New York, you have so much changes from a neighborhood to another, and you have a high density, so you really want to have a detailed data set. And as a sensitivity check, we also use the PRISM grid, which is larger, so it's 4 kilometers, and we use that to show that we basically find the same result. For the census data, so we only use the 2010 census data, so it's fixed throughout the time period for a demographic group and a socioeconomic group shares. And we use 2 different levels of the census data. We use a block group level for ethnicity and race, so it's between 600 and 3,000 individuals. And for socioeconomic data, we use the tract level, which is a little bit larger. This is just like this is a block group, this is a tract group. And what we do is that this is just like to show you an overlay of our 2 data sets in the New York area. So you can see, well, here you have Manhattan, you can see it with Central Park in the middle. And what you see is that basically we need to assign a tract to a grid in the temperature data. So basically we just do area weighted. So we do this matching by just assigning a tract to different temperature grids. Finally, last piece of the data. So what we do is that we're really interested in looking at extreme temperatures, because we know that these extreme temperatures are the most important as to their effect on outcomes such as productivity, mortality. If you look at only, for example, the daily average temperature, you might not capture really the temperature information you want. So to get at the extreme temperatures, we use a measure called degree days, which capture extremes. So it just captures for how much and for how long temperatures might be above a certain threshold. So for example, here the blue line is the bound. So for us for heat, it's 30 degrees Celsius. And the degree days would just be like the area that's in blue here. And you can find an analogous threshold if you look at degree days below a certain threshold. And finally, this is just an overlay. So here we just did an average of the degree days above 30 degrees in our sample in TopoWax, overlaid with a map of New York with census tracts. And what you see is that you have a lot of diversity. So the blue is kind of a lower degree day, and the yellow is warmer, is more degree days over the course of our time. So it's an average. And what you see is you have a lot of diversity, and this is also sort of a motivation to go further into our analysis, as we think we might see those differences. So now I'm going to run through the results that we find from this analysis. So first, this is just like what happens over the course of our time period. So it's population weighted to account for the fact that you have different population densities in different parts of the country. And it's for degree days above 30 degrees Celsius. And what you see is basically when we use our 2 data sets, we get the same trends. And as you would expect, it's getting warmer. So that's something that we know, and we can see that in our data. If we repeat this analysis, but by differentiating by groups, so this is by demographic groups. So this is for white residents. You see that also following these trends, they're exposed to more degree days at the end of our sample than at the beginning. And this is for black residents, and finally for Hispanic residents. And you can see this big difference. You can see that different demographic groups are exposed to different degree days above 30 degrees across our time sample. And this is sort of the answer to the first question that we asked. So yes, we do observe, when we look in our data, we do observe this difference. also observe this for income, that high income are exposed to less extreme heat than low income. And if you look at cold, you actually will see sort of a reverse picture. So you have that now white residents are exposed to more. First, you see that the trend is going the other way, as we expect, so it's getting warmer, less degree days below 0 Celsius over a time period. And you see the reverse picture in the fact that white residents are exposed to more cold degree days than black residents, and Hispanic residents are exposed to the least cold degree days. So in the analysis I will show you afterwards, I'm also going to talk to you about some city scale analysis. So this is just to show you the different urban areas that we look at. So it's the 14 largest urban areas, and together they make up for about 1/3 of the total US population. And you can see that they're spread out around different parts of the US, but still more centered on the East Coast, but this also implies that we'll get at different climates across the country. Okay, so what we do is that we are really interested in looking at the beginning of our time period and at the end of our time period, and kind of to understand what is going on between the beginning and between the end. So what we do is that we fit a trend line in our data set, and basically we predict the value in 1970 and predict the value in 2016. And this is what you see on this graph is, so on the x-axis you have the degree days above 30 degrees Celsius, and so the y-axis is just a different categories, so different socioeconomic and demographic categories that we are using. And on this graph, what you see is that, so the beginning of the arrow is the predicted value in 1970, and then the end of the arrow is the predicted value in 2016. And what we see on this graph is something that we saw before. First, when you look at it, you can see that the different categories or different groups, they do not start at the same place. So in 1970, you have this heterogeneity. But the second thing that you see is that the size of the arrow between the groups is not the same. And this is kind of the second really important point that we want to underline, is that, for example, you see that the size of the arrow for Hispanic residents is much larger than for the size of the arrow for white non-Hispanic residents. And so what this means is that the difference between the groups, so in this case between the demographic groups, has been increasing over time. So not only do demographic groups start with a differential exposure in 1970, but over time, their trends are different. So you really have that Hispanic residents are getting more exposed to extreme heat compared to other demographic groups. And this is the same graph, but so for the largest, just focusing on the largest cities in the US, so those cities I just showed you on the graph before, and you can see a similar picture. So now, if we, like we did before, if we kind of look at what's happening for cold, so degree days below freezing, below 0 degrees Celsius, you see the reverse picture. You see that, first of all, everyone's exposure to extreme cold is decreasing, and you also see different size of arrows. So what you see is, for example, that white non-Hispanic residents' exposure to cold is decreasing more than, for example, Hispanic residents' exposure to cold. So you really have the same dynamic but reversed for cold, and what this means is it's basically a compounding effect, as people do not like being exposed to extreme temperatures. So there's a distaste for extreme heat, extreme cold, and here you see that one group is being more exposed to cold, while another group's exposure to extreme cold is decreasing, which means that compounded, the differential trends across groups are widening. And so now we want to get a little bit more at understanding better what that variation is and how it's playing out. So here, this is a graph that's presenting you. So you just have the zero presents the total population exposure, and what each arrow shows you is how each group is moving compared to the total population exposure. So, and this is also for extreme heat, and it is between the different cities. So what this means is that it is comparing being in one city compared to another, and it's not getting at what's happening within a city. We're kind of decomposing our global effect that I showed you before into two different effects, the first one being between the cities. And strikingly, now, if we look at what's happening within the cities, so this is showing at the difference, looking at how each population group is compared to the city total average, and re-aggregating those differences. So it's kind of having fixed effects for cities. And what you see is that you also have a lot of differences. And so I think this is a really interesting finding, that really it's not only due to the fact that different groups live in different parts of the country. It's also linked to how where residents live within a city and what type of temperature they are exposed to within a city. So now I will talk a little bit more about the last part of our results, which is the climate amenity value. So this is just showing you, this is the estimates we use to compute our own results from a paper by Albouy et al. In 2016. And what this is showing you is that in this framework, we estimate that everyone's optimal temperature is around 65 degrees Fahrenheit, and that every time you move away from this temperature that is optimal, you're going to have a sort of disamenity, which is computed, as I was explaining at the beginning, at sort of as a fraction of your income. So if you spend one day at 30 degrees Fahrenheit, you will have a loss in amenity that would be like a small fraction of your income. So what we do is that we take this and we apply it to our degree days estimates. And we do this because this way you can kind of have an image of the overall distribution of the temperatures. Like what I showed you before, you were only looking at a bound like 0 degrees Celsius and 30 degrees Celsius. And here you can see the different bounds, and you can see that overall, you still have that difference in across these different groups. You still have that different groups are exposed to different values of amenities, and that the size of your arrow is still very different. For example, you still have that even though white non-Hispanic residents have a lower climate amenity because they're exposed to more cold, and in this computation this comes out to give them a high climate disamenity, but the size of the arrow is much larger for Hispanic residents, for Black residents, and non-white residents. So you really have that these trends are in the sense that minorities are increasingly their climate disadvantage is increasing compared to white residents. And lastly, I'm going to present you the results on the housing prices. And what you see is that, so this is temperature on the bottom, and on the y-axis you have, so it's log house price trend. And what you see, basically, is that you have the middle temperatures, prices do not seem to respond, but they do seem to respond to extreme temperatures, in particularly for extreme heat. So you really have the log house prices respond to extreme heat. So you do see that there's sort of a translation into housing prices of this temperature. And lastly, as a conclusion, what we see, we do observe these baseline differences in exposure to climate disadvantages and in exposure to extreme temperatures. So you really see that minorities, low income, low educated, or no no college degrees, there is this disproportionate exposure to extreme heat. And of course, I'm talking more about extreme heat here because looking forward into the future, this is really these trends that we want to be considering, in particular with regards to policymakers. And we do see that, conversely, white residents tend to be disproportionately exposed to extreme cold. And on top of these baseline differences, we have that these inequalities over the past 50 years have been widening in terms of exposure to extreme heat because of this thing that you have more extreme heat that might affect residents differently. And lastly, very importantly, you still have these differences within small geographic areas, such as cities. And thank you so much for listening to me, and I look forward to your questions.
Okay, I'll open it up for questions. Sure, and if, don't mind going to the microphone.
This is Ilknur. I'm an economist at the Federal Reserve Board. Clara, it was a very interesting paper, and I kicked something, and a very good presentation, actually. I just have one question. Well, I am new into this literature, so this might be totally obvious, but I'm just wondering, what if this disproportional exposure is the choice of individuals? So putting differently, you show us that these Hispanic people are very exposed to a significant difference to heat. But what if they want to live in these warm environments, right? And then more Hispanics go there, the other Hispanics follow. Putting differently, on the whites to the extreme cold, for the US, these are the areas more like on the middle, right? And I mean, unfortunately, these are the areas that they do not really like non-white or non-American people. So maybe they just don't want to go there. And they are more exposed because the pool is bigger.
Yes, absolutely. So in this analysis, we don't look at sorting mechanism. We don't get into why these people might choose to live in a different area. So we don't really answer that question with this data, but that's definitely something that we really want to answer in future work and look into it. But yes, it could be. Like, for example, here, when we do the climate amenity analysis, we assume that people have homogeneous preferences for different temperatures across the groups. And that's not something that's necessarily true, but at the same time...
I think it's a strong assumption indeed. Yeah.
Yeah, but also I think that the baseline that people have a distaste for extreme heat and extreme cold is something that holds across all our different demographic and socioeconomic groups.
Thank you.
Thank you. Oh, great. James is lining up.
I figured that'd be the way to do it. Really interesting presentation. I have one quick clarification question, and then a real question, and then a suggestion. Do you use changing population between your two population maps between your periods?
No, so we hold the census, we use one census vintage, so we're fixed. And that's something that in future analysis, we will incorporate different census data. So yes, the population shares are fixed for now.
Do you know how much of this effect is being driven by increasing urban heat island effect versus changing background climate? Partly because I think that part of these groups might be benefiting from the growth of their cities around them.
Yes, so no, that's not something that we can entangle with this data. Or it's not something that we have looked into to just really kind of identify the heat island effect. But it's, yes, it is certainly in there, I think.
And then my suggestion would be that you start out by saying, micro level information is super important. This is still aggregate, but you could extrapolate between different levels of aggregation and sort of figure out, okay, based on how far you've gone, if you were to take this all the way down to the person and think about the variation at the level of the individual, how much different would that result be? I think it'd be very interesting.
Yeah, that's a great point. Yeah, I think it would be really great to have to be able to identify each person in particular because, for example, we don't know, this is only outside air temperature, and if we had data at the person level, we could, for example, know if this person works outside or inside, if we could tie that. So then we could have a much more precise estimate of what their actual exposure to temperature is. So yeah, that would be awesome.
Thanks.
Any other questions? So no, sure.
Thank you for this presentation. I'm also very new to a lot of this, so this is very exciting to see. I'm a big map nerd, so I really liked seeing the maps at the beginning of tree coverage in the city, and then the effect on people and their hospitalizations based on heat and things like that. I'm curious how some of these maps might overlay with data that you found about the changes in extreme temperatures, and then how that was affecting different people with different identities and different backgrounds. Also kind of thinking about like how there are geographic differences within New York City, for example, where trees are isn't exactly just a natural thing. Air conditioning and things like that also, but I'm just kind of curious about some of these human and physical geographic factors overlaying with what you were seeing on these like micro levels and where people were and yeah, I guess like and the changes of the number of degree days.
Thank you for your question. Yes, I mean I definitely think that for example that the tree coverage difference might play an important role, and it's there's a lot of recent work also on the role of tree cover and how it can impact, for example, mortality within city. So yes, definitely, like those two maps, I presented them as like separate motivation for the analysis, but they are tied. Like you could think that there's a link between them, for example, that areas that might have extensive tree cover might see less heat-related hospitalizations and other variables. So I definitely think that they do come into account. I don't think that, for example, we're really measuring for heat stress-related hospitalizations. Our data doesn't really incorporate air conditioning, so as I was saying, we don't know what temperature people are exposed to inside. That might also be a big driver, so for that it's a little bit more complicated to answer, but for tree cover, I think it would be an important factor, definitely.
Thank you very much.
Of variation within metro areas. And I understand tree cover, like in a place like New York, might be a big factor, but I'm thinking in a lot of coastal areas, especially large, geographically large coastal areas, that distance from the shore might be a factor, and that, pricing, it's very expensive to live if you're in, say, Los Angeles by the shore versus in the valley, and, similar things in Florida. I just wonder if that's something that you looked at, just because it seems like an interesting question. Thanks.
Yeah, thank you for your question. Yeah, absolutely. I think that there's definitely that kind of like a breeze effect also when you live close to the shore. But I mean, I see it as a similar mechanism to trees in the sense that it will like have a sort of cooling effect very locally. And so absolutely, I think that could totally be a driver in those coastal cities that when you live closer to the shore, I mean, you're exposed to other environmental damages as we just saw, but for temperature, it's definitely like I think it plays kind of a similar role than the tree cover in the sense that it's also kind of an amenity that's more valued. So yes.
So line up behind the microphones. Feel free, and Tim.
Thanks, Clara. This is super interesting, and I think it's really striking to see these differences across these different groups and how these within and between differences kind of compare. I'm wondering if you've thought at all about the role that humidity might play in some of these. It seems like the Hispanic population is really sticking out here. I'm guessing that's mostly because of their concentration in the Southwest, which is going to be more dry than like the South or the Northeast. So I think it's possible that even if you look at something like a wet bulb temperature, the within differences are going to be even bigger compared to the across differences if the Southwest is more dry, and so you don't have like as high of a wet bulb temperature as you would in other places at comparable temperatures. I'm wondering if you've thought at all about the role of that.
Yeah, thank you so much for your question. Yes, that is something that I've discussed and thought about, and it would be really great to see to redo this analysis with wet bulb temperature because, yeah, I know that humidity is super important, even when you look at these questions of the effect on productivity, for example, or mortality. It's the combination of heat and humidity that matters more than just heat on its own. So it would be really interesting to be able to do that, absolutely.
Sure. Yeah, thank you for the presentation. So your presentation does...
Come a little closer to the microphone, maybe.
Sorry, can you hear me now?
Yes, thank you.
Thank you for the presentation. You did identify in your presentation the relation or correlationship between the absence of tree protection in low-income communities to the rising warm temperatures in those communities. And I was just wondering, like, besides the absence of tree protection in those communities, were there other factors that you considered, such as industry pollution in those environmental justice or low-income communities? And like you talked about in the inverse, we have exposure to cold in high-income communities. And I was wondering, with the presence of tree protection in those communities and the role that they play, such as carbon sink, was this something that you could also make the connection to, considering that carbon is one of the chief primary contributors to increase in heat or climate change?
Thank you for your question. I'm not sure I got the last part on what you were saying about high-income communities and cold.
Yeah, the correlation with the fact that high-income communities have more tree protection in those communities than low-income communities, and you said that research has shown that they have increasing exposure to cold, and I'm saying that trees act as carbon sink, and carbons are chief contributors to increasing heat or climate change. Is there a correlation?
Okay, thank you for repeating. So first, in this analysis, we really focus on the temperature, so we don't look at other environmental dimension in this paper. So we're only able to answer for temperature. But in the literature, you see that often, like, you do have you have compounding effects between different types of overexposure to environmental damages. So it's something to explore. But in this paper, we really focus on temperature. And then for your question, no, I mean we just focus on we don't really look at like the role of trees in the carbon sink. I don't think we really focus on this analysis. We really just want to look at, it's pretty focused on the temperature, so we don't really take into account these other dimensions.
Sure, go ahead.
Hey, very interesting presentation. I have a suggestion similar to the wet bulb temperature. So when you're defining the hot and cold degree days, it's the same no matter where you're looking. But so I went to grad school in Texas, and here 86 degrees is super hot, but 86 degrees in June in Texas is a cool day. So have you considered allowing the definitions of hot and cold degree days to vary by city, maybe top 5% day, bottom 5% day for the local area or something like that?
Thank you for your suggestion. Yeah, that's a good idea. Yeah, because it's true that we need to, I think it would be interesting to address this heterogeneity, and have kind of a relative measure to the climate. But yeah, I think when we look at the within city analysis, we kind of try to understand what's going on within cities, but it's not really relative to the bounds. The bounds are still fixed.
Thank you.
Thank you. And our last question, Doug?
Thank you. Was really struck by the findings for the within city differences, and I wondered if it could be possibly extended to map these within city trends to something like zip code level data on hospital admissions. Is that sort of fine enough geographic resolution, or do you sort of really want the block level? And then secondly, and I guess this would be sort of more of a case study within, but are there things like tree planting programs that you could look at? And I'm guessing there's sort of a nonlinear response to tree planting, and the timing thereof it sort of kicks in after 5 years or something like that. That's it, but thank you for the great presentation.
Thank you for your suggestions. I think so I haven't really looked at the question of hospitalizations. I think it would work for some urban areas, but maybe some geographies like Manhattan might be too dense to get at something. But in other areas that are urban areas that are much more spread out, it would definitely probably, it would be interesting to see. And yeah, that's a great idea for tree planting programs. I think there's other policies that kind of separate, create differences between urban areas, like redlining. So there's other things, kind of policy setups that could be really interesting in this framework, I think.
Okay, thank you very much, Clara. I will turn it over to Christian to present.
Awesome. Thank you very much. And thanks to the organizers for including us on the program. This is the unintended consequences of mandatory flood insurance. This is joint work with João Santos, who's here as well today. And I'll preface anything I'm going to say with the fact that I was told to put a gray background on all of my slides yesterday, so these will look somewhat atrocious, but hopefully the content will carry us through. Now, what are we interested in this paper? Well, very briefly, floods can be pretty catastrophic, especially for mortgage borrowers who get wiped out, and for the banks that have lent to those borrowers who are now facing defaulting customers. So mandatory insurance that's compulsory for everyone to have, can mitigate some of these concerns. Because everyone has insurance, no one's going to default because of a flood, and lender concerns are assuaged, and so the market, a negative equilibrium doesn't occur, the market continues to be stable, and lending continues to happen. Now, on the other side, of course, mandatory insurance can be costly. It can be costly for the borrowers who have to actually pay for the insurance, and it can be costly for whoever is tasked with actually monitoring mandatory adherence to those insurance contracts. And so this is basically what we end up asking in this paper. We're interested in, does mandatory flood insurance affect mortgage lending? And if so, what are some of the characteristics of borrowers or lenders or mortgage contracts that affect that? And if you're interested just in the first couple of minutes, I'll give you the answers up top. Yes, mortgage lending is negatively affected by mandatory flood insurance, and it's most pronounced for low-income borrowers, so borrowers at the margin, who have to make these extra payments and get shifted out of the market. And it's pronounced as well for non-local banks, so for distant lenders that don't have a local presence in a community, for whom asymmetric information issues might be largest, and who then end up pulling out of those communities. And obviously that has implications because where banks locate is not necessarily random. And all of what I'm saying here, you might say, okay, that's self-evident, that's somewhat obvious. I would argue that the trick or the unique contribution of this paper is in part trying to prove a causal relationship between the mandatory insurance and these ultimate outcomes. Because insurance mandates don't occur in a vacuum. They are a reflection to some extent of underlying flood risk. And as a consequence, we want to disentangle the mandatory insurance component from any sort of flood risk response that we'd otherwise be capturing. And that's what we try and do in this paper. And hopefully by the end of this, I'll have convinced you that we're able to do this. It's a short presentation, so I won't go too deep into literature. It's worth highlighting perhaps at this point a couple of papers that have dealt with similar issues, especially when it comes to sort of the unintended consequences of regulation. Peralta and Scott have a paper that looks specifically at the NFIP, and I'll talk more about what that is in a second. But they look at that some borrowers get trapped in communities or even get drawn into communities of high flood risk because of the NFIP. And a recent paper by Parisastri uses somewhat similar data, uses flood map changes, and I'll talk more about those in a second as well, but uses flood map changes in a slightly different way than we do and is focused somewhat on Florida. So I'll be able to show you a large case for the US as a whole. Now, I've talked about the NFIP and flood maps. What do I mean with that? It's probably helpful to do some level setting so everyone's on the same level. Following sort of disastrous floods in the 1960s along the Mississippi Valley Basin, the federal government decided that it would be nice to have insurance that prevented sort of the catastrophic outcomes from flooding. And so the NFIP, together with FEMA, brings out what are called flood maps. These are maps that designate a special flood hazard area. These are regions in which flooding is likely to occur at least once in 100 years. And so at least does a lot of the heavy lifting in that sentence. But theoretically, an average person in that community stands a 1% chance of being flooded in any given year. And as a consequence, is supposed to buy flood insurance. And the government has been, or FEMA in general, has been trying to incentivize the uptake of insurance over time, and successive, regimes have brought in more mandatory rules to really enforce insurance uptake. Today, any sort of mortgage that is supposed to be securitized by a government agency, that's Fannie, Freddie and all those, so any conforming loan that's supposed to be securitized, will have to have flood insurance if it's originated in a flood zone. Similarly, if a borrower is supposed to be eligible for damage assistance after a catastrophic event occurs, they will have to have bought flood insurance if they were eligible to do so. And finally, and sort of in gray a little bit where we are now, any loan provided by a regulated institution, so a bank ostensibly, even if it's not a conforming loan, will basically have to ensure that the borrower has flood insurance if they're in a flood zone. So in the early days, the NFIP rates were aggressively subsidized to incentivize uptake. Since the 1980s, the rates have been increasing, even for sort of grandfathered in insurance contracts. But more importantly, borrowers are now supposed to buy rates at quasi-actuarial prices. Now, how actuarial these prices actually are is a matter of some debate. And Tesla et al. Have a recent paper that talks about how even just repricing to accurately reflect rising sea levels is going to cause an extreme spike in prices for some communities. And that's a topic for down the road. But theoretically, new mortgage contracts originated now that have to buy flood insurance have to do so at quite expensive rates. What's also important for our purposes here is that lenders are the ones tasked with ensuring compliance with these mandates. So even if the lender securitizes a mortgage, they're technically on the hook if it turns out after the fact that the mortgage was supposed to have flood insurance but doesn't. So for our purposes, that's relatively important. So 3 possible hypotheses of what can happen if you enforce mandatory insurance. The first, very simply, is sort of the idealized version. Concerns are assuaged about possible damages done by floods and possible borrower defaults. As a consequence, lending increases because there's no negative market equilibrium. The other side, or the negative side of the argument, could be that the expenses drive certain borrowers out of the market, especially sort of low-income borrowers will be most affected by that, and aggregate lending decreases, aggregate mortgage lending. The last hypothesis is that aggregate lending can again decrease because distant lenders are unfamiliar with a local market and are unwilling to actually monitor borrowers' adherence to flood insurance. And the reason that's a possibility is because for those of you, in this audience probably knows a lot about the NFIP anyway, but if you look at sort of the catalog of insurance products that is available, finding the exact specific product that is right can actually be quite difficult because it depends on the nature of the house, the slope it's on, the basement it has, whether the basement is finished, whether it's half open, not open, and it requires some knowledge about the actual property to be able to choose the right kind of insurance contract. All right, what kind of data do we use for our analyses? Well, the two important data sets are first the Home Mortgage Disclosure Act database, which tracks a lot of borrower characteristics for all mortgage applications in the US. And we can see obviously the application and whether the application is accepted. And importantly, we have borrower income, borrower race, and the important part here for us as well is the borrower location. And borrower location is actually only available in the confidential HMDA, but it's important because we can pinpoint the census tract in which the borrower is applying for a mortgage. And we also have nationwide FEMA maps. And we have FEMA maps from 2013 to 2021. And I'll delve more into that, why that's important in a second. But I think we're one of the only researchers who actually have a complete set of historical FEMA maps for the US for that time period. And because it's quite difficult to get them, FEMA sort of retires old maps quite quickly, and it's hard to get at historical maps. So we got these in part by begging FEMA, and in part by brute force pulling them from the sort of the historical servers, causing an outage for a little bit, but that's between us. So basically we end up having 2013 to 2021 maps, which is quite useful. We merged that in with sort of disaster data, which I think has been talked about already today, about the actual flooding damage that occurs in local regions, and we merge in sort of information on bank location and county and census tract characteristics from the Census Bureau. Now, I talked about why we have maps from 2013 to 2021. Why is that important? Well, the maps aren't static. They get updated at somewhat regular intervals to more accurately reflect the flooding risk. Now, that's the ideal. FEMA is supposed to update the maps at least once every 5 years so that no map is older than 5 years. And they've been making good progress recently. I'll caveat everything when I say with the fact that they've been making good strides. But even now, a lot of the maps are quite outdated, with at least a fifth of them being more than 15 years old. And that, if you go backwards in time, that problem becomes a lot worse. So at the start of our sample in 2013, a large percentage of the maps, almost half, were considerably older than 5 years, just by virtue of the fact that they hadn't gotten around to updating them. And the updating process itself can be cumbersome. So it takes time, and it depends on the involvement of the community in question. The community can either sort of help or fight the updating process. The surveyors go out, survey the area. It's put to the community for sort of debate ultimately, and community engagement can affect that. Some communities don't want their map extended, and so they'll fight tooth and nail. Others do want them extended. And then even after all that, after the whole process goes through, it usually takes FEMA another year or two to actually turn the maps live and bring out a new effective map at a certain point in time. All right, so what do we do? Well, we take these maps and we digitize them, and then we overlay them on census tracts in the US. Now, census tracts, as was discussed earlier, are relatively small. They're around 4,000 people. So this means that census tracts can be wildly different in size. Right? In a place like New York, a census tract can be one big building. If you go out towards Wyoming, it can be a large percentage of a county. Overall, though, the census tracts that are more populated tend to be closer to waterways. And for those census tracts, we can categorize them as either being at flood risk because they're covered by a special flood hazard layer, or not at flood risk because they're not covered by a special flood hazard area. And what we can see in the top picture, and I do apologize, I realized too late that this is red-green, so apologies to anyone who's red-green colorblind. But what we see in the top picture is that overwhelmingly the US looks green because the large census tracts are not risky in terms of being a flood risk. And so overall, it looks pretty safe. But if we zoom in to certain areas, and even on this large sort of projector, you can see you can get very, very, very small census tracts, especially if you zoom in. This is the second picture here is the New Orleans area, and you see New Orleans and Baton Rouge. And you can see that very small census tracts can quite accurately be categorized as being in a flood risk or not a flood risk. And for those census tracts that are sort of partially covered by a flood zone, we may have to make an assumption. And we end up saying that in a census tract that is X% covered, the average borrower who's applying for a mortgage has an X% chance of falling under the insurance mandate. That's probably a lower bound estimate, given that usually the census tracts tend to have their population clusters closer to waterways, but that's sort of the assumption we have to make. So if the census tract is only half covered by a flood zone, any random borrower that's applying in our data has half a chance of being covered by that. We also look at changes, and so here you have part of the Delaware coastline, and you can see in 2018, the map was actually quite outdated, and it went through 2 updating rounds in 2019 and 2020. And so at the end of 2021, you see that the map looks very different, and you see that the percentage share of the areas that are covered by sort of the special flood hazard layer and therefore require mandatory flood insurance have grown. And that's important for our empirical methodology. So what do we use all this stuff for? Well, our basic specification relates outcome levels at the mortgage borrower level, so whether or not a loan is accepted and the amount of loan, so the size of the loan, if it is accepted, to the degree to which the borrower is likely to fall under the insurance mandate. And we include a whole host of borrower characteristics and region characteristics. We include bank fixed effects, bank time fixed effects, actually county time fixed effects, to absorb as much other variation as we possibly can. And then we try to see, okay, does the flood insurance requirement relate negatively to mortgage outcomes, to loan acceptances and loan size? Now, you might rightly argue at this point that the level of a flood map captures flood risk to a certain extent. Right? Even if they're not accurate, even if FEMA gets critiqued for inaccurate maps, to a certain extent, we cannot argue our way out of, even with all the controls that we have that include past disasters and that, we cannot argue our way out of the fact that some residual flood risk is definitely going to be captured in the flood map level itself. But that's where the flood map changes are so important. And because the flood map changes occur somewhat sporadically, they are not necessarily 100% driven by flood risk, we can account for a lot of characteristics, including sort of recent flood damages, including county and census characteristics, that can accommodate a lot of sort of the other information that we're trying to extract here. And the exact timing of when a map goes live will be unrelated to the actual underlying creep of flood risk that the census tract is experiencing. And especially relevant because it will usually be announced what the new flood map is going to look like long before it actually goes live, at least a year before it goes live, which means that the actual timing of when a new flood map goes live doesn't convey flood risk, it just conveys the insurance mandate in that year of becoming effective. And sort of empirically, the neat part of this, and FEMA helps us out by being slow and sporadic and having a very stochastic updating process, because we get that randomized effect there. All right, I'm going to skip some summary stats because there's not that much time. I'll just go right into some baseline results. So here we have the chance that a loan is accepted. So the outcome variable here is whether or not an applicant gets the loan. And we assume here acceptance means both the bank says yes and the borrower actually takes the loan in the end. Right? Because there are such things as soft rejections where the bank ostensibly says yes, but at 100% interest rate. So good luck. Which we would consider to be a soft rejection. So we take only whether the money, when the money actually flows, which is about 70% of applications in HMDA are considered acceptances in that way. And we see, does it matter whether you're in a flood zone or not? And it does. So being in a flood zone and falling under the sort of insurance mandate has about a 1.6% decrease in the chance of a mortgage being accepted, all else being equal. And this, if we can sort of interact our variable of interest, flood zone coverage, with some other characteristics of interest. In this case, we have the borrower's FICO score for a subset of all people in the HMDA. So if we use borrower FICO score as an indicator of sort of creditworthiness, we can see that it's overwhelmingly concentrated, a negative effect. So overwhelmingly concentrated on the low end of FICO score borrowers. And similarly, if we interact our variable of interest with a dummy, denoting whether or not the applicant has low income for their census tract, so is the applicant below median income for the census tract, we see that, again, the effect is disproportionately stronger for low-income applicants. Now, again, you might say, okay, well, flood zone coverage itself is not what we should be looking at, so we look at the changes in flood zone coverage, and this relates to, is the borrower suddenly covered by the insurance mandate from one year to the next? And the effects there are even more pronounced. So being suddenly covered by an insurance mandate is related to a 9.7 percentage point decrease in the likelihood that a loan is accepted. And again, the effect is much more pronounced for low FICO borrowers, where the effect is concentrated, and significantly more pronounced for low-income applicants, right? So they're looking at an almost 20% decline in the chance that their loan is accepted, all else being equal. That's a significant drop in the chance of being accepted. We see somewhat similar results if we look at loan-to-value ratios. So loan-to-value obviously is the amount of money you get relative to the value of the property you're buying. So larger loan-to-value ratios means you've gotten a larger mortgage. Smaller ones means you had to put down more equity. And here we see that the baseline effect goes through. The more likely you are to be covered by the insurance mandate, the smaller the actual mortgage. Even if it's accepted, the smaller the actual mortgage ends up being. The effect on income goes through as well. The effect on FICO score is somewhat reversed here in this context. That's unfortunately a sample construction issue in that the nature of people who end up getting credit in flood zones tend to be high FICO anyway, so you end up getting a strange top of the sample selection issue here. But by and large, our results here would say that being low income and having low FICO scores on average means you're much less likely to receive a loan if you fall under the insurance mandate, and you're going to receive less if you do receive a loan. All right, so it's worth looking perhaps at a few more splits in the data because I think it's relatively interesting. So here we interact our variable of interest, the change in flood zone coverage at the census tract level, with a few other sort of characteristics. The first column just shows you the baseline regression again. That's the same thing we looked at earlier. And the columns 2 and 3 interact our variable of interest with bank dummies. Basically, what kind of bank, what kind of lending institution is this? We split the sample by conforming and non-conforming loans. So conforming loans are those loans that are eligible to be securitized. They fall below the conforming limit. It's around 500,000, but it varies by county. And non-conforming loans tend to be what we call jumbo loans. They tend to be large mortgages that can't be securitized. And what we see at the very top line here, I don't know if the laser pointer works. It does not. The very top line indicates that the baseline effect of falling under the insurance requirement actually is positive in the jumbo loan market segment. That means these loans are more likely to get a mortgage. These borrowers are more likely to get a mortgage if they're applying in an area that's recently covered by flood zone. The negative effect is more pronounced for smaller loans, but it's particularly more pronounced if we look at sort of national bank there, that's NatBank in about the fourth line. It's particularly pronounced for large national banks. And these banks are sort of the banks that don't necessarily, aren't chartered at the state level, they're not community banks, they're sort of the larger banks. They in particular pull out of an area after it's been designated a flood zone and after it has that sort of that insurance mandate that comes with that. We also see that large mortgages relative to small mortgages are more likely to be accepted. That's sort of a confirmation of what we saw in column 2. Large mortgages here are mortgages that are above the insurance limit. And as was said in earlier talks, the insurance limit is around 250,000. So mortgages that are above that level, we would expect to be more risky. But those are the mortgages that are more likely to be accepted. And finally, we see that local banks are, in relation to national banks, local banks are more likely to lend in communities that fall under the insurance mandate. Taken together, these results point to the fact that distant lenders that aren't local to a community, lenders that don't have a local presence, are more averse to lending. And we take that as evidence that information asymmetries are at play here. And so I'll defend that a little bit in this analysis here. And so here we interact, again, our variable of interest with a number of sort of first relationship level, I guess, coefficients you'd call them. So how many branches does the bank have in a given zip code? How important is that zip code to the bank? That's usually an indicator of a number of things in the banking literature. But the presence of a bank will be important. And we see here that if the bank is present in the zip code, it sort of attenuates that negative effect that we see from falling under the insurance mandate. We see also that the more power local banks have, the stronger the effect. Now, local banks tend to have a lot of power in very rural communities where they are one of the few actual lenders that are present, and other banks will sometimes lend there, but it'll be more distant lending, and they'll sort of do that via branches that are not local. But we see the effect is more pronounced in those cases. So in these sort of more rural communities where local banks are stronger, the effect is much more pronounced. So you're much less likely to get a mortgage accepted. Similarly, if your market share as a bank is higher, you're more likely to accept a loan. Now, the last two columns here are what I would consider to be great evidence of the smoking gun, that these are in fact costs that are at play in these results. And what I mean by that is the NFIP has certain regulations that communities have to follow and abide by to have access to the NFIP's insurance program. And communities can violate those rules, and they can be admonished, and if they fail to comply after being admonished, they can be suspended from the NFIP. And that means that they don't have access to the NFIP insurance, so there's no subsidized or quasi-subsidized flood insurance available to these communities. But the way the laws and the way the things are formulated, it also means that the insurance mandate falls away in the time that the map is suspended, and during the NFIP suspension. Because the borrowers are supposed to buy NFIP insurance if it's available, and if it's not available, they don't have to buy it. So perversely, if communities fail to cooperate for an extended period of time, they get suspended, and that suspension has implications. But the implications here are that lending actually increases. So the flood risk hasn't changed. The map's still available, technically. Right? You can still go and look at the map. It's still there. Nothing has changed about the community. It's just that the community is not participating properly in the NFIP and has had its membership revoked, I guess, for the time being. Sometimes communities come back in. Sometimes they don't. But for the most part, they tend to join back up after dealing with whatever issues they had. But the important thing is here, we see, okay, if we interact map suspended with changes in flood map, we get a positive coefficient, but it's insignificant. But maps don't really change if they've been suspended, so that's very weak power there. But we see that if we look at the levels, a map being suspended is associated with a sharp increase in the chance that your mortgage loan is going to be accepted, because you don't have to buy insurance in that year, and so the bank is more likely to grant you access. So it's an interesting sort of the smoking gun in the negative way the insurance works here in disincentivizing lending, especially to lower income people. And as we saw on the last slide, disincentivizing lending into smaller loans, right? Larger loans are more likely to be given. Why is that? Larger loans are more profitable. It's easier to give those loans relative to the cost of having to monitor the adherence to the insurance mandate, right? You have a fixed cost of monitoring adherence. That fixed cost rises if you're very distant to the community. So you have no information about what the community looks like, what the borrowers are like. You have no relationship to some of these borrowers. So that information symmetry rises, and that cost of monitoring rises. And so the larger the loan, the better you're going to be off with a high fixed cost. And we can see, I don't have these slides here, but if we interact some of these coefficients, we see that the largest concentration of result occurs for low-income borrowers that are trying to borrow from distant lenders, right? Lenders that they don't have a relationship with. And that has aggregate implications. And I'll talk really briefly about the aggregate implications. Something I don't have on the slide here that is perhaps worth mentioning is that aggregate applications actually fall. I haven't talked about any of that because I've talked about within applications. So the fact that someone applies and has all these characteristics, do they get a loan or not? But what is also interesting to look at is just the aggregate number of applications that go in. This, of course, has a number of sort of confounding effects. We'll just take that with a grain of salt, but aggregate applications tend to go down around 5% after flood zones increase. And then on aggregate acceptances, and again, this is at the aggregated at the census tract level, so a lot of the individual and bank level controls are missing here. So again, take this with some grain of salt. But aggregate acceptances go down by around 6%. So on average, that's a large swing from the number of applications that go in to the number of actual acceptances that come out. We're looking at a significant curtailing in the amount of mortgage funding available to certain communities after sort of the flood map expands. We see that the average income of borrowers actually has to be larger if they're borrowing in a flood zone, especially after the flood zone increases. So that's in thousands. So you're looking at around $5,000 more in income that's necessary. The income differential here in column 3 is something that I computed trying to take into account borrower characteristics before we go into sort of this regression framework at the census tract level. And there the effect is slightly attenuated by borrower characteristics. So you're looking at maybe a $2,000 difference in applicant income of applicants that go in versus accepted income of people who have a mortgage accepted at the end of it, right? So you need more money going into it. And the largest effect comes actually in amount differential. That's sort of comparing the amount that people apply for in the beginning versus the amount that people get at the end of it. And trying to keep some borrower characteristics the same, we end up with $29,000, $30,000 less in mortgage credit that comes out at the end of it. So these are not insubstantial aggregate effects that come by as a result of all of this. Right. So to conclude, what we show in this paper is that the flood insurance mandate does reduce lending along both the extensive and intensive margins. It's harder to get a mortgage, and the mortgage you do get will tend to be smaller. That'll be most pronounced for low-income borrowers who are at the margin of borrowing anyway and get pushed out of the mortgage market because of the high costs of insurance. But it's also more pronounced for lenders that don't have a local branch. Right? And given that lenders will often select their local branch networks based on profitability, local branches will be random, that has more aggregate implications. Because if you don't have a bank relationship, if you don't have a pre-existing bank to do business with, that can knock you out of the mortgage market again, just by virtue of the fact that distant lenders aren't willing to engage, and local banks, if they're not there, can't make up that slack. So that's another important feature. It's worth highlighting, I guess, at this point, at the very end, that we're not making a statement about the efficacy of flood insurance in general. In the paper, we do relate flood damages with delinquency rates, and we do show that higher insurance uptakes do somewhat attenuate delinquencies after a flood. So there is a positive effect of having flood insurance. That's not what this paper is necessarily about. But what we do show is that there are even well-intentioned and somewhat functional regulation can have unintended consequences. And in this case, these unintended consequences are crowding some people out of the market. So to the extent that it's not socially optimal to limit coastal living to the rich, and to the extent that it's also not optimal to curtail lending by certain banks in certain regions, it's worth considering these sort of side effects when implementing regulation. Alrighty, I think that's it so far.
Thank you. Maybe I'll start with one question. You mentioned the fact that flood map changes are endogenous to local communities, and if where it gets extended, where it doesn't, that's a bargaining and negotiating process. You at all worried that it's kind of the people who end up getting the flood insurance new map have some other characteristics that determine that?
That's a very good question. So I think the extent to which the bargaining works to sort of reduce the map size can correlate with borrower characteristics. Absolutely, I agree with that. And I think we try to account for that in what we include in sort of the regression setup. I mean, I think the biggest driver of map changes weirdly enough, so if you just relate map changes to characteristics at the census tract level, you won't get much. But if you relate, if you look at both positive and negative separately, both map growth and map shrinkage is strongly related to local income. So that sort of speaks to your point that more affluent communities have some power to steer that. And that is an issue that we're aware of. We try to address in the paper by including as many sort of county and census tract level characteristics that include well, obviously income, but also that includes sort of the degree to which they've cooperated with the NFIP before, because you can, if you cooperate really well with the NFIP, if you're really good and really like engaged with the process, you can qualify for certain reductions in the insurance premium that your residents have to pay. So looking at the degree to which they've done that in the past as well to try and account for the endogeneity in map changes is what we try to do. Hopefully we can do that convincingly, but that is a residual concern. Absolutely, I agree. Thank you.
Thank you. And we have a few folks around the mic. We'll maybe start there.
Christian. So I'm wondering if you can define again loan acceptance, because what I think I heard was it's the decision that both the lender provides the opportunity for the loan and accept, is an approval of a loan, and it's also the borrower accepts the loan. And I'm wondering where the decision's being made to want to locate in a flood area. So is it that the lender is willing to extend that loan, or the borrower is making the decision to live in a flood zone?
That's an interesting point. So you're absolutely right in how we define acceptances. So it has to be sort of both parties meeting of the mind, where the bank says yay and the borrower actually takes the money. To the implicit concern there, who is locating into flood zones, that gets captured. We sort of abstain from that in the sense that we argue if you're applying, you're at least somewhat willing to locate here. And then we're looking at within applicant, I guess what happens within applicant, and we say, okay, if you're relatively on the lower end of the income spectrum or on the FICO spectrum, you end up having a harder time, even given whatever preferences you tend to have for coastal living, right? You sort of weigh the amenities of coastal living with the chance that you're going to get flooded, and you're okay with that, even within that. To the second part of your question, looking at aggregate application numbers is actually also interesting, because you do see there is some tendency towards, over time especially, towards applications going down a little bit in areas that are considered higher flood risk. So that there is that component to it. And there, I would agree with you. We don't argue that's sort of related to the insurance mandate. We just sort of say, okay, that's in part probably preferences as well.
Absolutely. Whoever was there, yeah, sure, go ahead.
Paper. I had a question about, if I understood the finding correctly, that basically the national banks are pulling out more than the local banks, and the local banks are the one providing the mortgages. And you saw that as a product of the local banks having better ability to monitor because they're closer to the borrower. So I was wondering a couple of things. One is, how is monitoring actually done? Like, I'm sort of wondering in this day and age, when I would assume a lot of the monitoring could be done electronically, how important is the physical location? And then a second question was going to be, well, actually, maybe you saw this as an information asymmetry where the local banks had better information. But I wondered, actually, maybe the national banks are the more rational actors and better informed actors here, because maybe they're updating to reflect the higher risk of flooding, whereas the local banks are not taking this more seriously. So maybe are we going to setting up a situation where we have these like community banks that are like really exposed to a lot of these flood-prone properties? And part of the reason I'm asking this is because my understanding is that these FEMA maps, even the most updated ones, would tend to be based on historical data about flooding. They would not be taking into account projections of sea level rise or greater flooding. So probably understating the risk, actually. And I wouldn't, so anyway, but really interesting paper.
No, those are very, very good points and very interesting points. I think, so in discussions with FEMA representatives, they sort of said that at least in recent times have been trying to, so getting at the second part first, they are trying to be a little more forward-looking in their approach, but I completely agree, like the maps are 100% based on past flooding data. So I think the other point is very interesting. So are the national banks just better at risk management, and is a reflection of their pulling out of these regions a response to their risk management system? I don't know, is the honest answer. The only sort of test we did that sort of speaks to that can maybe attenuate that concern a little bit, is when the maps tend to be posted at least a year before they go live. And so you can see what the map is going to look like. And there's very little response, there's some, but very little response to the map sort of coming online. There's a much stronger response to the map becoming active. Which I would take to be, if they're good at risk management, they would see the impending map change, and they would pull out in advance of that. But it could also be that they're just not, they're not paying that much attention, but they're paying some attention, and then their risk management updates when it goes live. That is a possibility. Our argument as to why it's monitoring is that several results sort of go in that direction, and it seems to matter too that for these national banks, whether they have a local presence or not. So they pull back on average, but they tend to have markets that they like, and that's corroborated by other literature that banks tend to reconcentrate on markets that they have a preference for, and there they don't pull out as much. So given that they have some where they like it and some where they don't, that sort of speaks a little bit to that they're not doing it purely out of risk management, but it's a very good point and a concern, absolutely.
I guess I can just say that emphasis added, because my question was exactly what hers was. Looking at the flood maps as backward-looking models versus the modeling that's being done to look ahead towards all of these different flood risks, especially from the financial modeling for like TCFD disclosures and stuff, you're looking forward for that. So are even the FEMA maps going to be relevant to the actual risk modeling and lending practices of the, and I found your conclusion about the larger banks having a little bit more exposure. That kind of stuff is really interesting. And have you extrapolated that into the future models of different scenarios.
So I guess my honest answer will be stay tuned. We're sort of working on exactly that, sort of the more forward-looking aspect, trying to see to what degree are these maps inaccurate if we move into the future versus the past, right? Because at some point there are some discontinuities that are likely to occur, as you absolutely point out. And so I think that is sort of where we're at now in terms of what we want to do for future research. But yeah, it's an absolutely relevant point. So thank you for that.
Yes. Looking at this through the lens of fair lending, so does this have the potential to become the new redlining using FEMA maps and flood maps for financial institutions to justify denying certain lending products and loans to certain populations, as has been historically done?
That's a good question. We haven't looked at that in this paper, but I think there is work that speaks to some of that, and they sort of they term it blue lining, where like the sort of the flood risk is taken as an excuse to change lending practices. It's a very good question. I don't have an answer to that in the context of this paper, but I think it's a possibility. Thank you.
So you talk about here whether a loan is taken or not. I mean, I'm curious what happens to prices, and the welfare implication is becomes like obviously much more complicated. Like say if this screening is making like is happening basically in the lowest decile somehow, but the second lowest or third lowest deciles are benefiting from lower prices somehow. So do you have any take on that?
That's a very good question. We don't, honestly. I don't have price data in this. It'd be worth looking at both house price data and sort of, we do have mortgage price data to a certain extent, both in the newer Hamda versions that collect mortgage price data and sort of rate watch. There's some response. It doesn't seem to be huge, but yeah, I guess looking at house prices would be very interesting as sort of another factor there.
So Zillow might have that data, like they made it public earlier. I don't know whether it is now
That's a
or
good
not.
point.
But if 5-10% of lending is like just being cut because of this new map, it should have huge impact on prices, right?
Yeah, that's a good point. I think depending on who's driven out of the market, it might be, to your point, different deciles that see different price changes, which I think corroborates some of the early literature on price changes in and around disasters, which would corroborate that. But I think that's a very good point. I'll have to try and get that data. Thank you.
Hi, Kirsten. So I have a question. Now that, if I understand you correctly, these local banks, local community banks are increasing their mortgage lending because they are feeling more comfortable, right? But at the same time, the overall has dropped. So, which means like then there could be two things coming: the demand side like dropping, so the households ask less, or the supply side is coming because of the crowd out of the big banks. I was thinking maybe it's not possible at all, but is there any way to identify these forces, or supply and demand, or maybe quantify them? Like, I'm making up 70% of this drop is coming from the households. It is because I was thinking that then this will gonna call two different policy actions, right? If it is coming to drop from the demand side, then policymakers should really play with this premium on the flood insurance. But if it is coming to crowding out the big banks, then it will be the Fed should do something for the banks.
Right. All right. That's a good question. So to the first part, which is the local banks lending more, I wouldn't say necessarily it's more. It's sort of the effect is not as negative, or the effect is reversed. So basically, they stay where they are by and large, and so the more national banks that reduce lending. And whether it being, so there definitely is, and this goes to Leslie's question earlier, there definitely is a demand component that we sort of sidestep in a lot of this here, because a lot of this is conditional on an application. So we have an application that goes in, and then we sort of look at whether or not it's accepted or not. So your point is absolutely valid in that, like, there definitely is likely to be a huge demand component that we're just ignoring because some applicants don't even and it could be that some applicants don't want to live in a risky area, but it could also be that some applicants, that we're underestimating the effect because some applicants don't even bother applying because they know they'll have to buy this insurance, and so they forego even the application process. So I think that's an absolutely relevant question. We can try and tease it out looking maybe at sort of historical patterns, but the further we do that, the less confident we are that we're capturing sort of just the insurance mandate as opposed to sort of also the creep of flood risk that comes up. But it's an absolutely valid point. So in this case, we're looking at applications that go in and then sort of at the lending decision that results as a consequence. Thank you.
One final question. Did you have one, James? Sure. Oh. Go ahead, please.
Okay. Thank you. I have a, I think this is really interesting. I have a hypothesis, and I wonder if you can speak to it. It seems like your results could also be explained by, I think a lot of lenders only see the flood risk when they actually get told that they have to buy flood insurance, and that they would be leaving because of that, not because of the actual insurance criteria. And then if you say, well, why would they be leaving? They're once they've bought the insurance, they're insured. But the lower income people probably have reason to trust less the service that they would get if something were to happen, and would probably have reason to think that they might have lower outcomes, particularly from the national banks compared to a local bank.
That's an interesting hypothesis. It goes to the question of, is this risk management, because we get this new information when a borrower comes in and we realize we have to monitor flood insurance adherence. And that's a good question. I would argue that hopefully the information content of any one individual applicant coming in is low enough that the bank isn't surprised by the fact that they that now this area is a flood risk and they now have to do that. I hope. It's an assumption conjecture, and I can't defend it more than that. But the point is absolutely valid. Like some marginalized communities may trust less in the process and the system, and that goes also to sort of the aggregate question of, like, are they even coming to apply for the loan in the first place, right? Are we massively underestimating the effect here because they've just opted out to begin with? And that is a very valid concern that I don't have the best answer for at the moment, but thank you for that.
Great. Thank you, Christian.